Hey everyone, we are here for our next session. We have Shayan, an engineer from Consensus Diligence, which does audits, amongst other things. He'll be doing a talk on oracles from the ground truth to market manipulation. And I'll let him take it from here. Questions, we'll go in the Ask a Question tab. Thanks.
Okay, thank you for the intro. So hey everyone, I know everyone's tired, so I'll try to get through this, and I promise I won't mention DeFi that many times. So yeah, I'm Shayan. I'm doing my PhD at Concordia University, and also I'm security engineer and smart contract auditor at Consensus Diligence. I've been working with blockchain technology full time since 2013, and I'll get there while I'm mentioning this. So this presentation is mainly about this paper that we're working on, which is called a systemization of knowledge and oracles from the ground truth to market manipulation. So it is a comprehensive research on the state of oracles. We look at all the possibilities, what is out there, how it can be attacked, how it can be improved, and how to rethink oracle designs. This paper is not out there, so if you want a draft, please email me or PM me at Twitter so I can send you a draft. So this is why I was saying 2013. So back in those days, before getting into talking about the paper, I need some going back in the history line and talking about why rethinking the way oracles are being implemented in today's DeFi projects is an important aspect of why in the whole ecosystem. Sorry. So back in 2016, my boss at the company I was working with came to me and he was like, there's this thing called Ethereum. Do you know about it? Sorry. And I was like, as the blockchain engineer in the company, I was like, yeah, I've heard about it and I read something. So he said that let's try to do a decentralized derivative market. And me being naive, I was like, cool, give me 2 days to learn Solidity and make a simple application to store a price of an exchange API. And a day after, I was like, wait a minute, who is calling this API? Where is this API being saved? So it got me more thinking back then. So for making a decentralized derivative market, what was needed? So basically a smart contract to implement the logic and also hold the funds. We needed a price feed for proof of concept. Back then, we used Ethereum to Bitcoin. And just note that there was no stable coins yet. Tether became an ERC20 token in September 2017, and also MakerDAO DAI white paper was published in December 2017. So this is almost a year and a half before all these. And the other thing we needed was basically UI and some users. So we needed makers, and as the smart contract for the proof of concept, we were the takers. So the smart contract would go on the other side of the market of user. So how was this working? So another thing, there was no automated market making to my knowledge back then. So it was a simple colored option contract, meaning that it had a simple logic. You would come to a contract, start a contract, you would define if you want to go long or short, and with the expiry time. And if the price was higher on the expiry time to max to double the initial investment, you would profit, and if it was less, you would lose. Simple as that, the simplest DeFi back then. Sorry for saying DeFi. And we needed a price feed. So back then, there was not that many projects working on oracles or just simply price feed. There was one project called smartcontract.com, which is known as Chainlink. They had a price feed which was only updated at 12 a.m. UTC every day. So once a day, the price was updated. And it was not really something I needed for that project. There was another one called Oracleize It, which now is also known by Provable Things. And it was a request and response to fetch the API. So that was basically what I needed for that. So I started using Oracleize It for this project. And for you guys that don't know, Oracleize It basically has this server and a smart contract, which your smart contract would send a request to. The server is watching it, and whenever the request comes, fetch the API and sends it back. So this was working, and one of my last interactions with them was a Friday afternoon when I was testing the contract. And I opened the contract, everything was working, and suddenly stopped working. Nothing was working anymore. I spent like hours just trying to debug this. And at the end of the day, I basically sent an email to Oracleize support saying that, hey, I have this problem. Do you know what's going on? And so weekend passed by. On Monday, I went back to work and I saw that there are no callback transactions coming to my contract. It was on testnet. And finally got an email from them that everything seems to be working and functional. So I saw that like after 2 days, this callback transactions that was supposed to settle the contracts were coming in. And I think there was like maybe the relay server was down or something, I'm not sure, but that made me realize that this is not the way I want to make this work. So I started to create my own price feed. And I call it Pricegeth, and it's on GitHub. I don't suggest you using it now because it's for 4 years old. But it was basically a server saving Poloniex prices, BTC to ETH. We had like Dogecoin and some others too, every 1 second to a database. And this Pricegeth server was listening to Geth for new blocks. And when there was a new block, it would see the timestamp, check the price of that time, and send it back to the blockchain. And at the end, the Pricegeth smart contract had all the prices and the historical price ledger on there for any smart contract to read, free to read. If this architecture seems familiar to you, like Town Crier basically uses the same thing, although they use SGX to prove the integrity of the code. And there are some new projects. One is DIA Oracle, which I believe is the same architecture, but maybe less open source. I'm not sure. So, and we had the UI. It worked great. Everything was fine. What was the next step? Probably an ICO. But, well, we decided to kill the project, mainly because it was relying on us as a central point to get the price. And that was the main entrance to the system. So we believed in decentralization and trustless technology. So for this project, which was called Velocity, it turned out that it was still centralized and we didn't want to risk the liquidity providers to be exploited at all cost. And this sentence is from the article at NewsBTC that said, it is too early for financial derivatives in the Ethereum ecosystem, and it seems that technological restrictions are to blame, which was mainly Oracle's. We, till today, are still following the same thing, but I'll explain further. So for that, we learned a lot of things. We published this paper on the feasibility of decentralized derivative markets. For those that are interested in starting something new, I suggest reading this paper. As I said, this is like 3-4 years old, but it has a lot of interesting things there to learn and on the design decisions. So back to the subject, oracles. So what is an oracle? What is the context? And is it as actually important to the rest of the system or not? So to define this, oracles are the bridges or gateways between real-world knowledge and the blockchain. And the oracle problem, most of you probably know, is still real, still a problem. But I think we are really close to have a solution for this. So we decided to systemize the knowledge, everything that we know, humans know about like oracles on blockchain. And the more we looked, most of the projects, either oracles or projects that were using oracles, they had one deep centralized point. And we looked at the research, most of the research out there, compared the implementations either for one or against another, and none of them claimed to be really comprehensive. So we were like, all right, let's put ourselves in the data's shoes and like go through this whole workflow and see what how it can be done and what can go wrong. And we listed all possible and known attacks in this systemization as well. Just to add something here, so a lot of this research could not define, let's say, Uniswap as an oracle, and we wanted to be comprehensive. So we defined this modular workflow of how oracles can be implemented and work. So these modules can be on-chain or off-chain. It really depends on the design. Some of them are optional that might not be relevant to one project or the other. And they can also slightly differ on the order that they use. And interesting enough, after defining this modular workflow, we ran into some new oracles and we were like, oh wow, this framework can be used to define and analyze any new oracles that we are seeing. So this is a module worker overview. There are 13 modules, which I would go explain one by one. So ground truth. This is the first challenge we faced, and also any Oracle design should face. That is, what is the truth? Is the truth objective or subjective? I want to ask this in the chat, but chat was disabled. So as an example, what is the real price of Ethereum to you? Anyone would say a different price based on US dollars, euro, other things. So we're not trying to solve this philosophical question here, but we may want to solve this question, that what is the best way to collect raw data from sources and aggregate them to have a reasonable data quality. So let's go further. So after ground truth, we have data sources, which are passive entities that store and measure the representation of the ground truth. So what are they? Like, there are multiple types. They can be a database or an API, anything like centralized exchange prices. They can be sensors, mostly used on blockchain-based supply chain systems like RFIDs. And there are humans, prediction markets mostly use humans. Also Nest Oracle technically uses humans to verify its prices. And smart contracts, like any on-chain markets such as Uniswap, could be used as the Oracle data source, and also a combination of them. So from here, we go to data feeders, which are the entities who gather and report the data from the sources to the Oracle system. So here, there are some important factors. One is the data authentication. How would you establish a data integrity in this system? TLSNotary is an example. Another is confidentiality and non-repudiation mechanisms. So if in any of this process the data was contaminated, we could see who was here to blame and who should be punished. Or mainly to detect mirroring attacks. So commit and reveal is a method to prevent or mitigate these kind of issues. Another one is the selection of data feeders, so we have a bunch of data feeders. We want to weed out the obvious outliers and the ones that don't have any skin in the game. So for that, there are different methods, centralized and decentralized. A centralized selection is similar to MakerDAO, Maker v1 Oracle, which used, I think, 10 defined oracles, and for every round they were using only these 10 oracles, or price feeders, sorry. And the decentralized approach similar to they have like a disallow list. What Maker v2 Oracle uses, I think, 13 data feeders chosen for every round. So it's not the specific 10 for all the rounds. Also, one really important factor is the collateralization here for decentralized selection, which is either reputation based or staking or both. So the collateralization is really important for the effectiveness of crypto economics of the system that you're using. So one of the projects called UMA tries to have a cost of corruption to be higher than profit from corruption. But deep down, they need some way of measuring this, and that is one of the centralized points that requires more research on that. Another important factors is aggregation phase. The process of collecting data samples and synthesizing the information to represent and inputting a single output. So we need one number at the end. Most of the projects use one statistical measure or more, like mean, median. So like Chainlink has different aggregation contracts you can use for different algorithm that you want. Or some other can use weighted methods, such as time, volume, and like as an example, Uniswap v1 was used as like Oracle, and it was only giving the spot price. But Uniswap v2 added this functionality to be able to define a time frame for the price. Or another method is random selection. So out of all the legit price feeds, use one randomly, which we know randomness on blockchain is an open problem still. Another factor here is the expiration date or stale data. Let's say your aggregation algorithm should count in a data that comes in and is old or is stale. Like, what should it do? Should it remove it? Should it use the old one? It should be able to handle that. Another factor is level of decentralization on the selected feeders, which it's more relevant for, let's say, prediction markets. So as an example, let's say the prediction market is on Nigerian election. Most of the users on the system are Western and like North America users or data feeders, and they all use Wikipedia as a data source. So whoever that edits the Wikipedia page basically tells everyone what is the truth. So that is another thing that you should consider. Another essential module in the Oracle design is the dispute phase. And some oracles don't have this phase, but this really helps safeguarding the quality of the final result. So we have two methods. One is preventive, which prevents wrongdoing, and one is corrective, which corrects the final result. For preventive, you can see it as like the city law. So it prevents people from wrongdoing because they don't want to be punished, but they cannot change the outcome if they do. Projects like Astria or Chainlink follows this method. The other one is corrective, which tries to correct the aggregated output, such as Augur or Nest Oracle. To expand on this, so corrective phase is really tricky, but really essential. So we need to figure out what is the outlier data and to remove that. It can result in restarting the whole system, which might be in a deadlock or halting the system. Also note that it could also be used to attack the correct data as disputing the correct data. The other thing we've seen is the dispute of disputes or dispute inception, which one of the example is Augur dispute phase can last more than 7 days, or in the case of Nest, the dispute is time bounded to prevent this to 5 minutes, which might not be enough. So an attacker can use some game theoretical approach to get the number that they want in this oracle. Now, whatever we talked about right now could be either on-chain or off-chain. So we have to decide as the oracle designer which one to choose. So on-chain modules, they're transparent, but they're costly. Off-chain modules, they're less transparent, relatively cheap, and possibly less secure. As one example is Chainlink that I think in September, the cost of aggregation, the data was about $450. And now, based on the talks out there, they are moving to a signature threshold implementation that the data feeders would pass the signature around off-chain, sign everything, and final result would be published on chain, which results in way cheaper execution, but less transparency. So let's follow the data in this process that we want to enter the blockchain. So for entering the blockchain, we need this server. We need this server that would be a bidirectional network connectivity between on-chain and off-chain. In this case, all traditional security issues with IoT devices, with servers should be considered. But most importantly, there are two. One is availability, that if the server goes down for any reason, this whole Oracle system is down and would not be functioning. The other one is data manipulation, which if the server gets hacked for any reason, we should be able to prevent any data manipulation, which a lot of projects use trusted execution environments such as Intel SGX or TLSNotary or even multi-party computation to prevent this. We separated the server's network from server to be able to discuss the attacks and how it is implemented with more details. So the server has two connections. One is the connection to off-chain component, which is the data source or the website API. The other one is the blockchain, which is basically the node, the broadcasting the data to the blockchain. So one side can be attacked through any man-in-the-middle attacks or even blocking the connection, which directly affects the availability. On the other hand, the blockchain side, there are so many research and attacks on partitioning attacks, meaning like Sybil attacks, Eclipse attacks, or any denial of service attacks on the peer-to-peer network. That should be considered while using such a design. Now we enter the blockchain itself. So the process of creating this data blob, signing it using a private key and broadcasting it to the network. This is basically like following the best practices of any cryptocurrency development. So the secure storage and usage of the private key is important. It should hold enough funds for the transaction gas to be able to send the Oracle response to the network, and also most importantly, the dynamic gas price calculation. So like we saw on Black Thursday, May or March, that MakerDAO oracles were not functioning properly because the gas price spiked for a period of time and they were not using a gas price that reflected the state of the network. So they fell behind and they were not confirmed, and it resulted in some damages to the systems that were using these oracles. Another one is the block creation, which mainly is the transaction inclusion block by miners. So if you have read these articles going around, Ethereum is a dark forest, that's good. If not, please Google and read. That's a really interesting read. So all the issues with the transaction ordering attack, front-running attacks, and the new discussions about miner extractable value are all a research field by themselves. And as the Oracle designer or even a data consumer, smart contract developer, you should be aware of these attack vectors and consider how they would affect your project. There are methods to mitigate these kind of attacks. Another one is the consensus, the algorithm that the blockchain is running itself to verify and append the next block of transactions. As you may know, Ethereum has small forks all the time. They're called uncut blocks. And there was one attack a while ago on EtherRoll, which is a betting game, which was really simple. Like the attacker was using small forks to view the oracle's response on this betting game and would correct his bet to reflect the winning number. And that's how they attacked EtherRoll, the betting game. Also, reorganization attacks or block reorganizations is something I should consider. And now, especially with the miner extractable value, it's something to think about further, that a miner might look at the profit they're gaining from the block reward with some other values they can get from some DeFi project and basically forego their block reward to jump on this new, more profitable block. So now we enter smart contracts. So basically, most of the oracles, they have this on-chain component to finalize the data and respond to the data consumer smart contract. So I'm not going to get into the details of this. We have so many other talks and research on this. So all possible smart contract vulnerabilities and defects on the code apply here. Also, like a lot of other projects use some governance method or governance model to decide on the parameters of the system. So one of the examples is a maker that has this variable called bar, which is the number of selected data feeders, or they have some other parameters like price feed sensitivity parameter, which any maker token holder, they can propose and vote on this. And if someone takes over like more than 50%, or depending on the proposal, enough maker tokens to vote on this, they can change this parameter and attack every other project that are using this oracle. And finally, at the end, we have the data consumer contract, which basically is the smart contract that needs this data for this business logic. As I said before, the defects on how it handles Oracle data, Oracle response, and possible security flaws are there. We're not going to get into details of that, but there are some specific ones that it needs to properly verify where this callback is coming from. Mainly like verify if the data is coming from the Oracle smart contract. One example is the Nexus Mutual bug in, I think, February, that the callback function was not checking if the transaction is coming from Oracleize it, a smart contract. In addition to that, it was not even, it didn't have any access control, so anyone could actually call that. So anyone could do replay attacks on the same callback function. Gladly, it was not exploited, but it was out there, and it might be there for any other projects that you should be considering. So this was all about the modular workflow that I discussed. And any Oracle out there, you can map it to these modules and try to map it and have a better view of like how that Oracle works. After this, we start to look at all the projects that are being used as oracles out there. So we found out that there are some projects that are an in itself oracles, meaning that they were designed to be an oracle, being a source of truth, like Chainlink. And there are some other projects that are a means to an end oracles, and that means they are a side product of another smart contract system, such as like Uniswap, any markets or on-chain exchanges. And we saw that on Uniswap V1, it was not a good idea to use Uniswap as the oracle, as there could be market manipulation to change the price and attack the system that is using Uniswap V1 as the oracle. There are some methods on Uniswap V2 that prevented this. The other thing that we did was we defined some other types of oracles, meaning that there are some types that are feed. That means any smart contract out there that want to use this contract, they can just do a call query. They don't have to send a transaction or request something. And the other type is request and response. And some other novel method is subscribe and response, which doesn't require two transactions. So in the paper, we explain this more, but one thing that I would love to hear from the audience is if there are any functioning oracles out there that is not listed in this example list, please message me on Twitter or email me, and we can discuss if it falls under which category. But the main thing is, so in this table, if you want to read it, internal external, meaning that it uses the data coming from the blockchain, and external, I think I found an error in this table. External means that someone outside is pushing external data in here. And I would be glad to discuss this further, but I think I reached at the end of my presentation here. So please get in touch with me about this research. I would love to hear the feedback from you guys and see how we can improve this. This is an ongoing research, and hopefully will be done in a month or so, and will be published a paper. So let me know if you are working on an Oracle project, or you're working on a DeFi project that uses an Oracle in a specific way that doesn't fall into this modular workflow, and I would be happily discuss it with you. I think I can look at the questions if there are any. Is this tech working? Is this dev stages? I think you're asking the question about the Velocity project, which was a project in 2017. It was working fully, but the project was killed because it was not decentralized enough. So I think I'm done. If there are any more questions, please feel free to ask either here or at my Twitter, or even just email me.
Awesome. Are you done with all the questions?
Oh, there was another question coming in. What does UMA fall on the comparison chart? So there was no comparison in this sense. Like if you're talking about this chart, we didn't really compare that. UMA doesn't really fall. So yeah, that's a good question. I have to add this to table. But the way UMA works is, so I'm in discussion with them on Twitter that there is one central point about market evaluation or the market cap that it is still using a centralized method, but using dispute methods, but I will be adding it to this table. Thanks for that point. I think I forgot to add this point, but yeah, with that, I'm done with the questions.
All right, fantastic. So this was a really great talk. If you want to share your slides on Twitter, we can retweet it out. Cool.
For sure.
So we're going to transition to our next talk now. Thanks again. It was really great.